Hello, pre-calculus students, and welcome to the lesson on power functions. And so it's good that if we start with the definition of a power function. And a power function is a function that can be written as f of x equals k x to the p. And there's some restrictions. It's that k and p are non-zero. Okay, so non-zero means it could be positive or negative, it just can't be zero. Real numbers. So both of these are non-zero real numbers. Okay. Now let's look at some examples here and see if we really get the idea of what the definition of a power function or what a power function really is. So the first one I have here, f of x equals x to the 1.5. I'm not sure if you can see clearly on the video here, in fact. Let me try to zoom in a little bit more. Okay. Well, looking at the definition, it is written in this form, k x to the p, so this is yes. Okay. And the power here is 1.5. The constant is just 1. Here, you have 4x plus 2, and the answer here is actually no, okay, because it cannot be written as kx to the p. This 2 here kind of throws everything off. Okay, so you cannot have some sort of a shift basically when you have when it's a power function. It's useful to have that shift in a lot of scenarios, but those just are not power functions. Okay, so we don't have to worry about any of that stuff. Next, you have f of x equals 1 over x to the third. And so it's helpful to convert this, to remove it from the denominator, and you get x to the negative third. Okay? And remember our definition that k and p have to be non-zero. They can be less than 0, they can be greater than 0. And so this is definitely yes. The power is just, the power here is negative 3, constant variation is 1. In this case, we can rewrite this function as 2.5x to the 1/2. The power is, of course, 1/2, and then the constant of variation is 2.5. So this has a lot more flexibility than our definition for polynomials. Okay, it's allowed to have fractional exponents, it's allowed to have negative exponents, it just can't have non-zero exponents, it can't have 0 exponents. Okay? Now the restriction is that it cannot have any shifts here, you can't add any numbers to it. If you do, it's no longer a power function. Okay, now let's look at some examples of using power functions or writing power functions. Write a statement as a power function equation. Use k for the constant of variation if 1 is not given. I'm going to cross out this part because it's not meant to be here. It's also grammatically incorrect. Okay? So let's start with the first one. The area of an equilateral triangle, the area A of an equilateral triangle, varies directly as the square of the length s of its sides. Okay? And so these two exercises here are really about interpreting text and making sense of it. Okay. Well, we know that A is the area. We know that S is the length of its side. Okay. And so our equation is going to be A equals something with S. And it's important to note that it says it varies directly as the square of the length of S. So as the square of the length, so S has to be squared. And then there's this very important word here that says varies directly. Okay? And this is perhaps a little bit of review from the days of Algebra 1, but varies directly means that as one number gets bigger, the other number has to get bigger as well. In other words, as S gets bigger, A has to also get bigger. Okay. And so this varies by some constant, okay, and we don't know what that constant is. So we put k in there, and this here is the constant of variation. Okay? And these two, a and s, they're variables. Okay? And that's it, where this concludes this particular problem. Okay? And it doesn't seem like we're doing much here, but you'll see in a couple examples from now the usefulness of being able to write this. All right, so let's try the next one. The force of gravity F acting on an object is inversely proportional to the square of the distance d from the center of the Earth. So here, this word here is important, inversely proportional. Okay? And inversely means that as one variable increases, the other decreases. Okay. So you have a force F, and you have some distance d. Okay. And it says that F varies inversely with the square of d. So because it varies inversely, k is actually going to be in the denominator, and then d, the square of d, so you have d squared, that's going to be in the denominator. In other words, as d gets very, very large, f will get very small because it's being divided by a large number. As d gets very, very small, f gets large because it's being divided by a small number. And we can also rewrite this as f equals, I'm going to rewrite this equation, f equals kd to the negative 2. So this would be a perfectly acceptable answer. This here also an acceptable answer. Okay? So here you have it, just a couple of examples of writing functions, or writing power functions based on some text that you're given. So I'm going to end this video here. I'm going to continue the next video with some examples of how to use what we've learned here.